working on solving multi-step equations. Okay, so we've gone over just solving one variable equations, and these ones are one variable equations, but they have multi-steps to them, so there's several steps. And what we're going to do is collect like terms. So we got to figure out what like terms are. For instance, 7x and negative 3x are like terms, which makes
4x.
4, there's no x, and 20, the constants, like terms. The very simplest first step would be is to get all of one set of like terms on one side, so the left side, and all of the other set on the other side, the right side. So if I was to move 4, and this is technically positive 4, to the other side, what would it become?
24.
Well, would we add 4?
Yeah, 20 plus 4.
I wouldn't be plus 4 because it's positive here. It would be minus 4 when we bring it to the other side.
Oh,
remember we talked about that? Yeah. The next thing is now that all of our like terms, right, all of the yellow like terms or the variable like terms on one side and all of the other like terms are on the right, let's simplify them. What is 7x minus 3x?
4x.
4x. And 20 minus 4 gives us
16.
16. The goal is to really isolate 4x itself. So now let's move that 4 to the other side. What will we get?
4x is equal to 16 divided by 4.
Which makes x equal to
4.
That's right. And if we plugged it back in, we check and get the right answer. Okay. Here's another one. Again, same idea. We want to get all of our like terms together. So what are like terms here? We have 5y, 3y, what else?
Negative 2y.
Yeah. Is that it for those guys?
Yeah.
And then what other like terms?
8, 16, and 16.
Great. Again, we want to get all like terms on one side. So we obviously want to move this negative 2y to this side, right? Because there's already 2 there. And this positive 8, we want to move to the other side. So we'll try to do this all in one step. One side will read 5y plus 3y.
Minus 2y.
Not minus 2y.
Oh, plus 2y.
Plus 2y. Exactly. And then the other side will read 16 plus 16, right? Because it's a positive.
8.
Yeah. Minus 8. So we did 2 movements in one step. Okay. Then we collect all our like terms. For instance, all of our green ones. What will they equate to?
10y.
Yeah, that's right. And what will our yellow ones equate to on the other side? A little tougher.
24.
That's right. Very good. So 10y is equal to 32 minus, yeah, you're right, 24. We want to get y all by itself. So we got to move 10 over, right? Which makes this
24 divided by 10.
Yeah. And really, we can just leave it as a simplified fraction. 12 over 5 would probably be easy if we divide both by 2. And our last example. Do you remember using distributive property?
Yep.
We take this term and multiply it by both. Yeah. So we're going to do that all in one step. So that'll give us 3a plus 15 is equal to negative 6a plus 4. Now what?
When you collect the like terms.
That's right. So what do you want to have on which side? You tell me, because it doesn't matter.
You have the algebraic.
We'll call them the variables.
3a and negative 6a.
Yeah.
The variables on the left side.
Sure.
And the constants on the right.
Great. Let's do that. Okay. So tell me what that's going to read.
3a minus 6a. Oh, 3a plus 6a.
That's right. Because when we move it, it goes the opposite operation. Always got to remember that. Okay.
Is equal to 15 minus 4.
Well, actually, no, because the 4 is already on this side. So the 4 stays positive. It's the 15 that becomes negative because it's the 15 we're moving. So sometimes it can get really tricky when we all move in one step. Okay, so always keep in mind whatever we're moving is what changes, not the stuff that stays. Okay? So then, when we collect our like terms, we have 3a plus 6a. What will that give us?
9a.
Yeah. And 4 minus 15.
Negative 11.
Great. We got to get a by itself, so we do what?
Negative 11 divided by 9.
So a is equal to?
A is equal to 1 and...
Oh, yeah.
1 and
2/9, or we usually leave things as improper fractions. Okay? So those are like three of the major examples you'll go through when doing